I think it's live. Hi, welcome back. I wanted to give an introduction to some of the stuff happening in Lab 3. So I've been hard at work. I'm pretty fastidious about tracking hours. So at this point, I'm about 30 hours into Lab 3, 30 working hours. I did 10 hours of reading, and I've done about 20 hours of development on this worksheet. So what I want to show you, I just gave you access. If you go online to this position, you go down to your Lab 3 location, which is here. You can download my lab write-up. I don't expect you all to LaTeX your lab write-ups, but I did. So this is actually my lab write-up for this lab. It's a little bit beyond where I'm expecting you to be in Lab 3. In Lab 4, we'll do some more of this. Because like in this lab, all I'm asking you to do is to derive the differential equation. I'm not asking you to solve it, right? But I wanted to solve it because I wanted to see where we were going. In addition to this, let's see. So I gave you some MATLAB code because I've made this claim that you all should be able to teach yourself MATLAB. When I learned, I just realized this morning, I learned MATLAB for the first time during classes in 2008. Some of you might have been born in past 2000, or like right around 2000, which means that when I learned MATLAB, it's over half your life ago, which is a little sad to me because I don't feel that old. I still feel like 18. The reason that's interesting, though, is all of the plot functionality that I used when I learned MATLAB is not the same as the plot functionality that MATLAB has now. So, as part of this lab, do you know what I've done for myself? Taught myself how to do plots in MATLAB. So, literally, I'm about to do something, which is to run the code that I provide for you. Let's go ahead and change this folder. This will produce, should produce, yeah, I'm not sure where those plots are. You see them?
They take time to load.
Oh, is that what's happening?
Yeah, give it a couple of seconds. It's gotta actually.
I'm hella sad right now.
Check, make sure that it's actually running. Sometimes the Excel sheet is named improperly.
How do I go to the command window again? You gotta dock the thing, I guess, huh?
Yeah, you gotta name.
Oh, I need the pendulum data, right?
Yes, so it's 01 underscore, then the rest of it's correct.
I see. So let me dock this sucker. Do you see, I should have done this morning. I was a little tired when I was working on this, as I'm sure all of you are. These freaking professors putting tests in week 6. Do you see what MATLAB's complaining about right now?
Yep.
Yeah, so it's telling me that I don't have my data set in that particular folder. So what I need to do is get that data set in the particular folder. So I think one way to avoid this is just to do the source file here. I don't know if I like Windows. And by that I mean I don't like Windows. You see it? All right, there we go. All right, so let's try this again. All right. So what MATLAB's complaining about right now is I provided this .csv file, and the file that I'm running, it can't find access to that .csv file, right? So what I'm going to do, in order not to spend the next 15 minutes setting this up, I'm going to go to the source file, and I'm going to just open that source file here. So this is the thing I used to upload this on MATLAB this morning. Let's change folder. What is it complaining against? Oh, there it is. Yep. Okay. So these two plots right here are generated by that full file. Right? So this is plot 1. I control, I'll show you this in a second. There's some nice features of this that are worth looking at. Do you see this little title up here? Figure 1, Engineering 11, Lab 3, Pendulum Graph, Position versus Time. I wrote that. At some point when I was teaching myself how to do this, I figured out how to turn off these little bars right there. Right? So if I didn't want those on my graph, this thing right here, the font for all that, we can take a look at it for a second. The color of these, the grid lines, the way that these dots are lined up, all of that I control. Right? I'm giving that code to you. Not a lot of teachers that I had give me code, but I feel like the best way to learn is to see other people's code, right? And I made this claim to you. You can teach yourself how to use syntax. Well, instead of like making that claim and then saying like, go do it, I did it for myself as an example of the type of work you could do. This is another one, which I'll show you in a second one. So this thing right here is one period of the pendulum. So the pendulum goes from the most right position down to the most left position, through equilibrium up to the most right position. All right, so in MATLAB, I try to document all of this stuff pretty well. So there's some nice documentation. I actually give my documentation like a solid F. So if I were to grade this lab, I would give myself an F on documentation because it's incomplete, and more particularly, we'll see this in a second. So you can read that documentation on your own time. So this should say import, not import. So the first thing that I do, what's the first thing that I do on this particular problem? Yep. And in this case, I'm telling MATLAB to start at row 3, column 0, and then I tell MATLAB that I want you to go from row 3 to row 959, and then I want you to go from column 0 to column 7. And the reason that I went from 3 to 959 is that the tracker software that calculates velocity does it using a finite element method. So if you actually look at the pendulum data, the first 2 rows of acceleration and the first row of velocity are blank. And that's because when they calculate acceleration, they do it looking backwards at 3 data points. And so what ends up happening is if I start at row 1 of this thing, my velocity and the acceleration data have no entries in those so that they're not realistic, right? So the next thing that I do, what did I do there? Now that I've downloaded all of this data, it's going to be in a matrix that is a 956 by 8 matrix, right? So now I'm going to start picking off the individual components. Row 1 of that matrix is going to be the frame number. Row 2 is going to be the... Wow, it's almost like I could read my own comments to figure out what it is that I'm doing, right? Oh, sorry, yeah, sorry. I mean, just read it. I'm telling you right now, if I graded this work, I would give these comments an F.
Ouch.
But this is only 20 hours into this project. wait a second. I'm not claiming that the way I'm going to grade your work is the way I grade my work. If I graded your work the way I grade my work, nobody would ever pass my classes, right? I'm going to grade your work the way that I think is fair given the constraints and everything, right? And if you stay engaged in this class, you're going to pass. I'm going to push you to a place where you're going to give me the best that you can give me in the time constraints that you have, right? Okay, so what's next here? I didn't remember how to calculate averages. So I went on Google and I said, how do you function MATLAB average calculation? And that took about 3 seconds. What is this vector now?
Displacement.
Yep. This is actually going to be part of lab 4. I think this lab we're going to extend into 2 because I want you to be able to compare real collected data against this. And then in this case, this script file was starting to get to like 100. I don't know. We can actually test this. How many lines of code it would be. So eventually, let's see. Let's plot position. So this is like 100 and. So it actually starts there, 47 minus 58, 111. So 86 plus 111 is like 200 lines of code. And then I want to do this for 4 different, I want to do it for velocity, position, displacement, and acceleration. Could you imagine how many lines of code that would be? Be a lot, right? So what I immediately realized is, what I'm really trying to do, there's kind of 2 things I'm trying to do. The first thing that I'm trying to do is collect the data from the actual experiment that I'm running. And then the next thing that I'm trying to do is plot it. Because I had this claim that you should know how to plot stuff in MATLAB. Okay, go learn it. So one of the reasons that I would give this an F is I haven't even started, like this happened about 6 hours ago. So like I created this function, I used the little function thing that we know how to do now, right? Notice, is any of that documentation valid? No, except for that, right? Okay. So one of the first things that I recognized, so let's go ahead and do this for a second. When I type in whose, can you guess what I get? Whose. What does whose tell me?
Who tells you what data is?
What's, yeah. What is the data? What type of thing it is? If I just go ahead and plot the time versus the position on this thing, MATLAB will actually produce a plot for me. I'm not sure where the hell that plot is at the moment. Say it again.
Replaces one of the pictures, so project general plots.
It's really frustrating to have 2. There we go. Yeah. So now I'm going to tell MATLAB, please in figure 3, plot the time versus the position. Okay, so literally the first thing I did is I literally just put the time in the position. Look at how ugly this is, right? I mean, it's pretty beautiful from the standpoint of that that's like a super easy command, but like immediately one of the questions I had is like what if I wanted to find this right there, right? So that tells me the y value is about 0.485, right? But like, let's think about this. So it looks like between, I don't know, 0 and 5. It's not really between 0 and 5 though, right? It's between like 1 point. Let's do between 1 and 3, right? Okay. So check this out. Find. Oh, let's do this. Find where t is equal to 1. What did I just find out? T, what is t? T is a long set of data, right? And what I'm asking MATLAB is find the index where the value of t is 1. What index is that? 29. Find the index where t is equal to 3. Format. Say it again. Yeah, because I'm in format bank right now. Okay, so what did I just learn? If I look back at that, at this thing, if I want to go from 1 to 3, what data points do those correlate with? 29 to 89. So now what I can do is I can try to find the max of x between 29 and 89. What is MATLAB going to return back to me? What is x again? X is the position data. And now what I've done is isolate down in the position between 29 and 89. And then MATLAB tells me the maximum position in this experiment was 0.488, right? Now I can immediately ask myself, okay, if that's true, find the x values that are equal to 0.488. Sorry, MATLAB is expecting a Boolean operator. So what x values have 0.888? Yep. Okay, so now I can also say, please find the min value of x between the 29th data point and the 89th data point. Let's find that. Oh, that happens twice. Now, if I want to find one period, I could ask myself, well, what is one period? What is one period? So now I know this one, and I know this one, and I know this one, right? So where does this happen? Where does that minimum happen? 38, 39, 40, 41. Where does the maximum happen? 79, 80, 81. Where does the min happen? 119, 120, 121. Do you see a pattern? What's the split in between them? How many frames are in between the max and a min? 40. How many frames are in between the max and the min and a min? 80. Where does the max start? 80. So if there's 80 frames in one period and I wanted to graph just one period, perhaps what I would do now, guess what? Every one of these commands I learned while I was doing this project. Okay, so now what I can do is I could actually say this to myself, right? I could say, okay, go ahead and go from 80 to 160, 80 to 160. What does that give me? One period of pendulum motion, right? So it is a sub-period. And then what I've done in between is I thought to myself, like, one of the best ways to like visualize this data is actually have a graph that does it pretty well for me. So if you actually look at this stuff, inside this I give you, one, access to exactly where I learned this, right? So if I wanted to learn more about how to deal with figure properties, what would I do? Run the following command, doc figure properties. So if I literally just pull this off, MATLAB's going to pull up something, right? Ask me if I read every word of this. No, I didn't. I looked for the stuff that I was most interested in and I focused in on that. Ask me if I wanted to read every word of it. Yes, I did, but then I was like, you probably want me to write my test, right? Control F. I'm not sure. How do I get out of this thing? Yeah, but then I'm down to stop streaming. I'm not really connected to the idea of streaming in this case, but how do I get out of this? But if I exit, I think I close the whole thing, right? I don't mind doing that. I'm not tripping about that. There it is. Okay. So if I go back here, and I'll let you now have access to this, right? You have this code. Let's change the figure color to blue and see what happens. Oh, sorry. It's going to get mad because I need to run the actual main script file. So what does changing the figure color to blue do? Change the background. So let's go back to white. Could you guess what this thing does? Figure name. Can change the name at the top of that figure, right? So like if I went ha ha ha, the one downside of modularizing your code, what do you see at the top? Ha ha ha, right? So now I can control that. This one I'll let you figure out what that does on your own. Here's the actual plot command. Here I chose tmin and tmax. What do you notice about tmin? What do you think tmin is? Is it well documented what tmin is? Nope. That's shitty code, isn't it? Tmin is the minimum time that I'm going to do. Which point did I choose for my minimum time? 80. What was true about 80? It was a local max. So I chose the first part of my graph to correlate with the maximum value that I knew for sure the pendulum did, right? In this case, I chose the minimum to be 900. You can kind of think about this. Here, I just actually like went a little bit above and a little bit below the max and min values. And then, if you want to know about axis properties, you can go doc axis properties. Axis color. Let's go green. Let's see what happens if I change the axis color to green. And you know what? I'm kind of sick of the other displacement plot coming up. Oh, that's kind of nice. I don't know what the hell I did there, but... Anybody know what I did there? Say it again. Yeah, it's kind of nice. So what does the axis color do? Ding, 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 ding. What have we got for? Yeah, it changes the color of the axis. So in this case, we said that the axis color was green. Let's go back to white. Axis box. Axis line width. Let's do something crazy like a line width of 6. What does the axis line width do? Yeah, it starts to control that, right? So like literally, I can have a lot of control over the type of work that I'm doing based on these little options. This was all new to me. I think this was MATLAB 2016. So like I felt really freaking old when I was doing this, right? I was like, these young kids don't even know what they have. When I did this, we had to scratch it in stone. Yeah, this is a little bit beyond the context. Anybody write LaTeX code? So this, if I document out this and I run this code, see how MATLAB's putting this in terms of the actual period of the pendulum?
Yeah.
So we'll analyze that in lab 4. I'm working on that. But when I'm labeling this, I don't care what the actual the values of those things are. What I care about is figuring out, can I map that back to pendulum values, right? So I'm just telling MATLAB in that line of code, hey, please label using LaTeX. So right here, you don't have to worry about this. I'm sure you all don't write in LaTeX. I hope you do, but I don't think you do. Anyways, you can analyze all that. The last thing that I'll kind of give you, and then you can play with this. Some of my students sometimes say, hey, Jeff, I want to control the colors of graphs. Okay. So I actually found the color of avocado in RGB scale. Avocado is this times 2 of I like avocados. They make me smile. I'm from California, so I also like Yale blue because I went to the UC system. So this is the Yale UC Berkeley. You see, like the UC blue is this blue. I call it Yale blue because that's what I found online, right? And then Cardinal for Stanford because I like the red. I don't know that I like Stanford money, but I'll tell you this much: I definitely like carrot orange. So this is the color of orange carrots, right? So then what I did is I broke up each part of the graph of this. Could you tell I was having fun? Yeah. My wife hasn't left me yet, God bless her.
Are they doing the colors in hexadecimal, or are they doing
Ah,
it looked like you had some crazy math.
so this particular set of colors, and the point of this is I just want to show you what's possible, right? Like I just set aside time, I did it consistently, and I thought to myself, what are some of the functionalities that I want? In this case, this was the color option of plot. So what I would do, the short answer to your question is this is RGB color scales on an 8-bit encoding
That's what I wanted.
from 0 to 1.
Okay.
Right, so in this situation, and I actually have, like, so right now in our class, we're doing the data, numeric data. So my dream MATLAB introduction is that we touch all 16 data points from the ground up in the first 18 lessons so that you know everything about how MATLAB encodes all data, so color data, pixel data, etc., strings, characters, etc., right? And then once you have an introduction to the entire way that MATLAB encodes data, we would then go into specialized modules, right? All of this stuff is done on labs, and right now I only have a certain number of hours in a week, right? So I can't finish all of that. But one thing that I'm really excited about is, here's a claim. Could you imagine if you could learn entire programming languages without ever having the need of a teacher, what that would unlock for you? I will claim it's actually not. To learn how MATLAB encodes data, I believe you need an advanced degree. To learn this stuff, I definitely did not need an advanced degree. I needed, at this point, 20 hours. Do you know why I gave this to you for free? Why would I give this to you? Yeah. And then also just, like, the other thing that I want to show you, do you remember you read these? Some of you have finished those articles, right?
Yeah.
Grade my code. Welcome to reading other people's code. Yeah, I want you to see what that's like, because when you produce code, a lot of you are thinking right now, I'm producing code for myself, right? Here, I've produced a bunch of code. You all have access to it and you want to use it. So here's an immediate challenge. I'm not going to grade on this. Right now, what we're going to do is Lab 3 submissions will be based on the Lab 3 write-up. So I'm not going to add any new Lab 3 material on there. Lab 4, however, could you guess what we're going to do in Lab 4? We're going to graph position, displacement, velocity, acceleration. Then we're going to compare the collected data that we used in Tracker against the solution, which means once you've derived the differential equation, you probably need to know how to solve the differential equation, right? So in this one, what did you do in Lab 3? You're deriving the differential equation from first principles. Could you guess what you're going to do by hand in Lab 4? Solve the differential equation in first principle. Once you've solved the differential equation and you've graphed the damn thing versus using actual data, you're going to superimpose the solution data on top of the collected data, and then you're going to start analyzing when does my model break down, why, what type of errors do I visualize in MATLAB. So that's there for you. The last thing I have to offer you today is, I guess I should show this to you. I was really kind of happy. I am kind of happy. I hope I'm happy. You all wrote problems, right? And I decided this quarter, I don't know if I'm going to do this every quarter I read all the problems. But this time I actually created a LaTeX document with all of your problems and your names. There are 3 people's problems who submitted to me that I did not write up, or maybe 3 or 4. And that's because the problems that they gave me were a little bit hard for me to imagine how to write a concrete problem. So this document are all of the problems that you wrote for me in the exact way that you wrote them. Oh, I should have been careful, huh? Because now you'll know who wrote the problems on your test. Don't be kind to each other. You all don't know about test corrections. We'll do that in a second. That's really funny. Yeah, you'll see that every problem on the test was written by somebody in class. There are single problems where multiple people wrote them. So do you remember this problem? Sorry, Michelle. You remember this problem? Yeah, so Michelle had suggested this, and somebody else in a different problem suggested that I have you encode numbers in base 8. So could you guess what I did? Yeah. James had a different problem that he wanted. He's not here right now. Here it is. You recognize this one? Yeah. So one thing that I noticed, this test was a little easy. I mean, it was actually hard. But I definitely think that you ever get into a test and there's that one problem that nobody knows how to solve? Yep. Yeah, so there was one like that for sure that I got, but I didn't put it on there because I don't want to be cruel because I haven't earned your trust yet. For the final, it would be really fun, maybe an ungraded, maybe what we'll do is we'll have 3 problems. You submit the standard 2 that you want a PC on there. And then one thing that I think would be a little bit fun is if you started to think about really freaking hard problems. I'm not going to put it on for grading, right? Your denominator will be the standard 2 problems. But what I noticed is if I only tell you you're going to write your own problems and I don't say challenge yourself, you're going to give me base level problems, right? Which is not a bad thing. I'm happy to have that happen. But I think, how many of you, when you were writing problems, if you took that seriously, recognize that a lot of interesting thoughts crossed your mind? What do I want to be tested on? What am I thinking about? What do I know? How do I, right? Guess what happens when you start writing problems that are really hard? Yeah. And then you start getting into the mindset of your professors, which means you can start to do that in other classes, but we'll talk about that later. So anyways, that's there for you. I have your tests ready to pass out. 2 people I was going to group with, so if I don't give you your test, I'm going to come see you individually. Is Wesley here? Adam? Wesley, do you want to announce what you're doing? Yeah, so I'm going to pass this out. Wesley has something that he's going to share with you. And I don't know, Wesley, you probably don't want to be on camera, do you?